So what is sorting? Sorting is the process of finding an order of a list of data, right? We know what it means. And formally, the input is static, possibly static array A of n numbers. And the output is another array, which is a sorted permutation of A. So what is permutation? Permutation is an array with same elements in a different order. And sorted means the item that comes first is smaller than the item comes later, all right? So for example, let's say the input was 82493, and after sorting, it is going to be 23489. So the later items is bigger than the former items, right? So it is very straightforward and easy to understand. And we say a sort or sorting algorithm is destructive if it overwrites A. So if instead of making a new array that is a sorted version of A, if you just change this A, then that sorting algorithm is destructive, all right? And a sorting algorithm is called in place if it uses O1 extra space, implies it is destructive. So rather than creating a new array B and make a sorted version of A, we just change the content or the order of items inside this A. So in this case, we call this sorting algorithm is in place, all right? Now, why do we care about sorting? In general, we could organize an MP3 library or maintain a telephone directory, blah, blah, blah. However, in computer science, quite a lot of problems become easy once items are in sorted order, right? We saw this in the last class. We could do binary search for sorted items. So this is an example. Given a sorted array, we can leverage binary search to make an efficient data structure. So we had a look at this last time. And I want to give a real world example, finding duplicated data. Without sorting, the code is going to be like this. Let's say we have a list of integers and we want to check if this array contains duplicated items. In such case, we need to iterate through this list twice. So that is the reason why we are making two for loops like this. So for each item inside this array, we are going to check whether all the other items inside this list is equal to this item, I. So for all the items, we are going to check whether other items are the same as this item, all right? So we are checking AI with AJ, all right? So if these two items are the same, they return true. Otherwise, we return false. So without sorting, we need to check all the combinations. And it is going to be complexity of O(n) squared. However, if the item inside this list is sorted, we don't have to actually check all the items. We just check whether the item of interest is same as the next item, all right? Because if they have the same duplicated item, then they are going to be neighboring to each other, all right? So in this case, we loop over the items just once. Rather than having two for loops, we have one for loop and just check whether there is an item whose neighbor is same as this item, all right? So in this case, the time complexity is O(n), right? So when items are sorted, the time complexity becomes from O(n) squared to O(n). So this is why we care about sorting algorithms. And there are some types of sorting. And in this class, we are going to cover 5 types of sorting. The first one is selection sort. The second one is insertion sort. Selection sort is kind of selecting some items and then conduct sort. And the second one is we insert some items to a sorted list. And bubble sort is like items are bubbling and the sorting is conducted. And merge sort is like merging some items. And quick sort is quite quick. That is the reason why it is called quick sort. So these are the types of sorting algorithms we're going to cover in this class. All right, firstly, we're going to have a look at selection sort. The strategy of selection sort is like this. We firstly find the smallest element and then recursively sort the rest of the list and concatenate the 2 pieces, all right? So the logic is like this on the right side. So let's say the first item was sorted and we find this smallest item and we exchange these 2 items, all right? So step by step, we find the smallest one and put them into the front, all right? And let's implement this selection sort together. So what we want to do is find the smallest item. And we receive a list of items. What we are going to do is first we need to check whether this list contains some items. So the length of this list is smaller than 1 or equal to 1. We're going to just return the list, right? And what we want to do is find min value index from this list. And what we want to do is recursively call selection sort. So from so let's write code first. So what we are going to do is we're going to exclude this item from this list. So this one is going to be n-1 items because we have not included this item with the minimum value. And what we are going to do is return so we attach the smallest item at the front and concatenate this selection sorted list at the end, and we return this item, all right? And how can we find mean value from this list? So we receive this list like this, and for k in range 1 to 8, we're going to compare all the items. And if ak is smaller than a mean index, then mean index is going to be k, and we return mean index. So in this way, we can find the mean value from a list, and we put this item out from this list, and then conduct selection sort recursively. And then we attach the smallest item to the front, all right? So this is selection sort, all right? Another thing to note here is we return a new array. So the input array is intact. We do not perform any operation for this list. So after this selection sort, the original list is the same as before, all right? So this is selection sort. The selection sort with recursion. And what we want to do is we are going to do selection sort with recursion plus in-place operation. So let's say we have millions of items. In such cases, if we create a new array, and that's going to be cost a lot of memory space, and we do not want such cases. We want to avoid such situation. So to avoid such a situation, we implement in-place algorithms. All right, this is to save some memory space. And how can you make this selection sort algorithm in place? Let's do this together. As we saw in this animation, what we are going to do is exchange items rather than creating new array. So that's how we are going to do in-place selection sort. And let's implement that together. So we are going to do in-place selection sort like this. In this case, we receive another argument, I, and this is going to sort AI from I to the end of this list, all right? So when we first call this function, we're going to call it like A0, all right? So we could put default value like this. As before, if length minus I is smaller than 1, we just return, all right? We don't have, we have nothing to do, all right? And the first thing we need to do is firstly find the mean index from this list, all right? But we need to find the minimum value from from index I to the end, right? So we need to change this a little bit like this, from range I to length A, like this, all right? And what we are going to do after finding the minimum value is exchange AI and AK, right? So that is like this, right? So after finding the minimum value, we put this value at the position of AI, and then the value of AI goes to AK. So because we call A0 first, the smallest value is going to be located at the index 0, all right, after this operation. And what we want to do is selection sort in place I plus 1, like this, all right? In this way, we don't have to create new array, and we could just exchange the values inside the given array. So after this function call, the order of items inside this array becomes different, right? So this is called selection sort in place. And another thing we want to do is in place plus iterative implementation. This is very simple. So how can you do this? We're going to make this recursive function into iterative function. So let's do this together. So we iterate from 0 to n minus 1. And we first find the min index as before. And what we are going to do is exchange AI and AK as before. So this is all we need to do, right? So what we've done is, firstly, we implemented selection sort recursively, pure recursion, all right? However, this one consumes a lot of memory space, possibly, if this input list contains a lot of items, like millions of items. And to avoid such a situation, what we've done is implementing in-place operation. So rather than creating a new item, new array, we exchange or the order of items inside this input list, okay? However, this one also calls itself, because it is a recursive function. And recursive function can be problematic when this list contains a lot of items, because it's going to consume all the space in function called stack. So what we've done is we turn this recursive function into iterative function like this, all right? So this is the first sorting algorithm, selection sort.